All right, I'm just going to start the recording. We can obviously cut off the beginning. And in about a minute, I'm going to move us from the practice session into the start webinar. My goal is to kind of do the introductions with this screen up here, just to build visibility around who you all are. And then I'm going to remove it and we'll just go to the Brady Bunch mode so that we can all have kind of conversation around that. And like I said, I have the quick introduction and then we should be through that relatively shortly. So I'll give it another probably 30 seconds and then we'll get going. I'll do a quick countdown. Just making sure everyone has the same 11:01. Or Rego, what are you at, like 10:58 right now? Just checking. All right. Let me just turn off my phone and we're good to go. All right, you guys, I'm going to push this to live mode and then I'll give it a second, then we'll do the introduction.
Sounds good.
Fabulous. Here we go. Good morning, everyone. I can see our participants are joining as we speak. I'll just give it another couple minutes or a minute or two here to let people finish getting into today's panel discussion, and then we'll kick things off. Fabulous. Excellent. People are still coming in. Great. So good morning, good afternoon, and good evening, everybody, and welcome to today's Forbes moderated panel titled The Future of Labs, Accommodating for Rapid Change and Equipment Innovation. How's everybody doing today? Great. Well, we wanted to start this event off making it very interactive, and we've got a very dynamic panel coming your way today. So if you can all just take a second, including the panelists, I want everyone to take a minute and just put in the chat where they're kind of joining us from today, where in the world. I know we've got kind of a big audience, so I wanted to see where people were coming in from. So if you guys want to take a second, put in the chat where you're coming in from and joining us from today, that would be fantastic. Boston, Toronto, Arlington, Virginia, Kansas City, Maryland, UK, I saw one, Italy, wow. Mexico, fantastic. I'm sure they have much warmer weather than we're having here in Boston today, which is where I'm from. Thank you. So we do have a very global audience too from Mexico. Very nice. So we'll be using the Zoom chat capabilities and Zoom Q&A for you guys to ask questions to the presenters throughout today's live panel discussion. So don't be shy, be sure to follow and put your questions in there. We want them to keep coming in. This is your chance right now to learn about how lab managers are reaching faster layout consensus and how laboratory equipment sellers and marketers are really increasing and accelerating sales in today's digital first world. So our panel discussion is being moderated by the one and only Alex Knapp. Alex is the senior editor covering life science and health at Forbes. And participating on our panel discussion today, we have Angela Carnwright from Thermo Fisher Scientific, Alistair Gammy from Ortho Clinical Diagnostic, Rego Lefwich from Canon Design, and Gavin Friend from Kaon Interactive. So at this time, I'm going to turn things over to Alex to kick off our 90-minute moderated panel discussion. Alex, welcome and thank you.
Hi, thank you for having me. I'm very excited for the panel conversation we're going to be having today, and also really looking forward to questions from the audience. I do encourage you to get those questions in. We're not going to do a question Q&A period. We're just going to incorporate them as we go. But one thing I think as we move into this discussion is that over the past couple of years, we've not only seen advances in technology, but also the way people are working as a result of the pandemic. And I'd really love to kick things off with you, Gavin, and talk about how what lessons we can learn from these last 2 years or so about the need for flexibility and adaptability and how your company has been helping its customers to do that.
Thanks very much, Alex. It's wonderful to be here amongst this esteemed group of industry experts. So thank you so much. The key thing that I think has been driving this innovation and change is that there's a huge difference between digitization and digital transformation. And what we've learned in the last couple of years is that just digitizing existing offline or analog processes doesn't always work in a digital first environment. And so what has been happening is people have been looking at how can we improve the process and make what are now necessary changes using digital infrastructures and platforms as the vehicle for making those changes. And I think that's the big difference between sort of where we were and where we are now, is that these interactive digital technologies are facilitators. They're not the goal, they're the facilitator of the goal. And the goal is to improve workflow, to improve lab operations, to be able to adapt and integrate new innovations faster. It used to be that if a life sciences company innovated a new diagnostic technique or a new method for a piece of equipment or instrument to be used in a lab, it took a long time for that to be integrated into the lab workflow. And so what is happening now is that as the world is becoming much more complex and as the pace of change is increasing, we've learned that these digital technologies are imperatives for us to be able to integrate that innovation across the entire spectrum and use those as quickly as possible to adapt to these macro forces. So the ability to use digital interactive engagement technologies has become now an imperative to be able to adapt as fast as we need to all of these macro forces that are happening in the world. And I think that's the big difference from what we've seen in the past, is whereas in the past, these were kind of nice to haves. These were sort of cherry on the top. They're now absolutely essential, because otherwise we would not be able to adapt and to be as agile as we need to as the world is changing so fast.
Great, thank you, Gavin. And I think with this idea of digital first, what's interesting about that is I think that, we think of it as digital first, but if we're changing workflows, that also means changing the way that we're actually doing the work in the lab. And I want to go to you, Angela, because you're working at Thermo Fisher. You're a lot of times working with your customers to provide the equipment they need. When things are moving faster, when we're adapting to new workflows faster, how do you adjust to that so you can meet the needs of your end customers? Angela, you're on mute.
Just realized that when it popped up on my screen. Sorry, everyone. So yeah, so we provide at Thermo Fisher both products and services to support pretty much every part of almost all scientific workflows. And, when we get called on by a customer to help with one piece of it, which is usually, we get a call for one particular product or maybe a protocol that they need help with. It's quickly taking us, the digital tools that we've created are quickly taking us from just discussing one product or application of that product to where it fits into the grander scheme of the lab itself and how that workflow happens in the lab. And it's important because that's how our customers, the scientists, look at their work. They're not thinking about it on a product level, they're thinking it on a protocol, or how does that protocol contribute to my overall science perspective. And so some of the tools that we've been using in this digital environment, and we created before the pandemic, really have helped us enable those conversations, especially in a virtual environment.
Great, thank you, Angela. And I think on that note, I'd love to get your thoughts, Rigel, on this in your work in helping on the design and construction of new lab spaces or revamping old lab spaces. We've been living in the past 2 years a time when we're ramping up really quickly, a lot of demand for things like diagnostic testing. Obviously, we're building manufacturing facilities in a matter of months where we used to be building them in years. How has this changed your workflow? I know we talked about this a little bit, you and I last week, but love to get your thoughts on how you've adapted and working with your customers on the lab design and construction process.
Yeah, it's a great question. It's really interesting. You know, the company I'm at, Canon Design, is about 100 years old, and if you go back and look at some of the the older drawing sets to build a high-rise building from the early 1900s, you know, they're only in the double digits, right? Number of sheets, and you know, you can't even update your earbuds without reading through 10 pages of legalese. And so what we found, especially with this idea of digitization, is, you know, we're working in computer modeling, and we're collaborating with engineers and designers, and we're making that 3D model where we can figure out ahead of time where clashes are happening and things like that. And so this world of translating that has become much more complex in the way we look at things. But at the end of the day, a lot of people don't visually see that 3D or don't see that. And so we're always looking for tools to help make it more simple and show actually what the space might look like and not be so technical. And what we've found, you know, in this process of collaborating, of speeding things up, is we have to be both completely technical and especially agile in this kind of age of supply chain disruption, and be on our toes when products aren't available. We have to substitute it with another one, and that might rearrange how we design the infrastructure of the space. But at the same time, the end user, you know, they need their process or their process flow to work, and so it's really been kind of translating these dual needs of use with the technical requirements.
Great, thank you, Regal. Alistair, you know, we've been talking about the end user of these things, the research labs themselves, and how we're enabling them to change workflows. You are the end user, so I'd love to hear how these last couple of years, how has that shifted workflows, and you know, what have labs been doing to kind of adapt to these new realities of more remote work and other kind of disruptions to the normal process?
Well, obviously, you know, things have become quite difficult getting in front of customers for one, but you know, I think we've looked at a number of digital enterprises almost. You know, for example, we were able to implement a full automation system in a customer lab in Latin America with no skilled staff. And I say no skilled, I don't mean it that we didn't have the implementation team there, and that was done by AR. That was pretty impressive. From a sales process side, we've you know, the fact that we can use a shareable 3D app really allows us to get more immersive, I think, with the customer. Gives us a better opportunity to really look at the aesthetics, because, you know, in many ways, you know, people can understand a 2D drawing, but when you start to see 3D, you understand the aesthetics of what your lab is going to look like, you know, when it's complete. And I think that makes a big difference. I do apologize for the change in light, but the sun is going down in Italy.
I guess there are worse places to be than Italy at this time of year. So no worries about the light. So Regal, kind of piggybacking on this idea of 3D and looking at that lab space in advance, do you see that as being a trend that increases in the future? I think Regal might have frozen on me, so I'm going to pop that question over to Gavin.
Well, I actually think that perhaps Angela has a more comprehensive perspective than I do, but I will say that I think one of the terms we've been talking about here that's a big change is this notion of collaboration. It used to be that work design, in other words, a workflow design or an instrument layout or anything, was done on an individual siloed basis. And two things have happened. One, as Angela said earlier, as we start engaging with people, the breadth of those discussions has been increasing. So rather than just focus on our one piece of the puzzle or one piece of the workflow, we start looking more holistically at how things relate to each other. And in order to do that, we have to collaborate. So in the past, a lot of this workflow was we would go into the lab, we would take some notes, and then we would leave, and somebody would do up a sketch, somebody would do a drawing, and then they'd come back. Sort of an individual siloed serial process. The big change here is collaboration. Now, rather than sending it off to a specialist, we're all participating in these processes. And two things happen as a result. One, we tend to solve the problem quicker because we're involved in a collaboration with people who are more knowledgeable perhaps in other areas. And then the second thing is we tend to solve more strategic problems rather than isolating just a local optimization of how to improve the workflow on this bench, for example. We actually start to think about, okay, how does this actually solve a larger problem? And looking at this visualization process that you talked about allows us to actually see some of those more strategic or holistic issues rather than just focus on what we're doing. So I think that the transformation that's happening is we're starting to collaborate a lot more with sometimes people that we never used to collaborate with outside of our divisions or outside of our product areas or even outside of our science workflows. And I think that is a huge strategic shift in the industry, which is going to have significant long-term benefits for all of the participants in that value chain.
Yeah, I'm gonna pipe in actually, because as Gavin was speaking, I mean, we've been using the lab design tool for nearly 4 years, I think, at this point. The example that Gavin gave of how we used to do things, you know, I would sit down with a client as a lab representative, and I would, you know, they would have a two-dimensional drawing in front of them. They would have cut out squares for the footprint of the items that they want to decide where they're going to fit into the space. And we would sit there and we'd kind of look around the lab and measure and be like, okay, this would probably work here. Oh, that plug doesn't work for that item, so let's move it. And it's truly two-dimensional. And I even had a client one time build a 3D model with cardboard and styrofoam to represent their lab, so that they could, because usually most scientists, many of them are working with very finite spaces, very usually small spaces, and they're trying to make it work. And so they go to this length to kind of recreate these spaces, and just so they can understand, like, can I actually work in this space? Does this placement of this item hinder my ability to actually do my job at the item next door to it, right? So when you think about the impact that has, the hours spent building those models and moving them around, we have saved so much time by moving to this digital format. And I equate it to when I renovated my kitchen, I used a tool to help me design my cupboards and my fridge. And I sat there thinking, why are we not doing this for labs, you know? So that's kind of where we started. And we've come a long way from there because we're now building full workflow solutions through the tool.
Sorry, I cut out earlier. It's the problem with remote collaboration, right?
Yeah, well, I'd love to kind of hear your thoughts on this, Regal, on what Angela and Gavin have been talking about vis-a-vis collaboration and getting people involved earlier in the process. Have you seen this in your side of the industry as well?
Yeah, it's something that has been happening for years at different levels. The industry calls it BIM, building information management, and essentially everything is a model of something. And a door has parametric capabilities, and you draw it in 3 dimensions, and then you can schedule it, and you can say whether it's a double door or that kind of thing. And it's been more of a recent thing, and it's still a little bit of the Wild West with laboratory equipment. And I think one of the things that when you say lab, there's just so many different types of labs. And so a production lab is different than, a scale-up lab or a pilot lab or a clean room microfab. And so there's been no kind of standardization. And I think part of the environment we're in now has been helping innovate, especially the process of communicating remotely and through space. And so I think it's the idea of collaboration is an issue every research institution is struggling with, because remotely we're missing those serendipitous moments, right, where we have that interaction. And I think any tool that can help us feel like we're in the same room together really helps with that. It doesn't sometimes substitute, being face to face or in the same room, but I think that whole discussion about being able to pull something up on an iPad, manipulate it, and you're not beholden to a technician to have access to where you might want things, or how to have that conversation, is important, especially in the early stages of envisioning what a project is, before other people are actually involved.
Absolutely. I 100% agree with you, Ragel. The collaboration piece is not just restricted to, as a provider of products, not just me and my client, but also all of the stakeholders that are involved in that decision. And it could be the architects, it could be the building planners, the building operations management people, the construction teams, the service personnel that are going to go in and certify and qualify the equipment that we're selling after the fact when it's there. So all of these different factors come together, and normally they would be a kind of a staggered approach, at least, the way that we previously maybe did things would be more of a staggered approach potentially, where you have you come in when it's your turn, when your item comes up. So when I'm now talking about refrigerators, let's call Thermo Fisher, it's time to bring in the refrigerator people. Well, guess what? We probably should have been talking when you were planning the building, so that we can make sure that your HVAC system can manage the heat load, or that your plug types are the proper plug types for the equipment that you're buying. So all of these different factors come way earlier in the process than when the product actually gets started, before they start thinking about, the actual use and the workflow in the laboratory. So that's been helpful for us.
And that point about not being able to see something in 2D versus 3D is important, because a lot of times a lab manager will have their space planned out and know exactly where everything wants to go, and then it'll get installed, and the health and safety inspector may come in and say, no, you can't, because they can't see it in the plan, or they don't have that same sense of the flow. And being able to see something in 3 dimensions and can really help convey being and occupying the space.
So Alice, it looked like you wanted to chime in.
I think from our side, it almost takes us to a different level of the conversation. It allows us to start talking about tube and test workflow. I think that gives us a helping hand, because much of the time you're trying to explain, a 3D, you do a 2D design and you're trying to explain what that really means to the customer. Once you've got that 3D design alongside the 2D, and you've done your simulation modeling, your capacity and capabilities have improved, the next piece is really understanding how that tube travels through that lab, and how do you actually look at that, and what does that really mean to the customer? Because at the end of the day, that's what they need to understand. That's what they really need to know. That's their burning question. What is going to happen to my tubes from the beginning of the day to the end of the day, and how am I going to get my work done? And how does your design give me a better opportunity than maybe your competitors, or even what I'm doing today? So for me, it's elevating the conversation. It's taking it on to the next level.
Can I just say something about that, Alex? Because I think that there's
Please do.
Thanks. Alice's point, I think, is really profound because there are multiple dimensions to what makes for a high performance lab, right? And one of them is the sample flow. You want to look at what's going on in the sample. You want to look at what's happening in the science workflow. But the other part of that, one of the other dimensions is the human workflow as well. One of the things that the instrument manufacturers have done is they have actually created common user interfaces for a variety of different instruments and created a much more flexible workforce to respond to what's going on in the labor market. And so what that means is that you now have to design for human workflow as well. You've got different walkaway times for different kinds of instruments. You've got different human workflows in terms of where they're going to get their consumables and how they're actually moving the science through the workflow. And then ultimately, you also have information workflows as well, information technology workflows. And so designing for all three of those and sometimes other multiple dimensions, I think has become a lot more complex than it used to be. And being able to visualize what's happening is actually a key element to being able to understand how optimal this design actually is. Because even though your tube workflow may be, or your sample workflow may be optimized, that might be a very challenging human workflow environment. And being able to, so you actually need to create this simulation. You have to create a digital twin so that you can simulate all of these environments. And it's because of that complexity that I think these digital infrastructures are now imperatives. It's almost impossible to think about optimizing without them.
So one interesting thing I want to piggyback off this, and and Regal, I particularly love your thoughts on this, is that when I've been talking with a lot of biotech companies over these last couple of years, one thing that they know is that they had to be able to scale quickly to respond to needs, whether it's a pandemic or they're looking beyond the pandemic. And I've also been talking with companies that are starting to get into the process of, we know we're going to need capacity for labs and for other things. We know we're going to need to hire, and be ready 2 years from now. What we don't know is necessarily if we're going with product line A, B, or C, depending on what the results of our research are. So how do you deal with that kind of uncertainty? Even if you get people collaborating earlier, if you know we're going to need this in 2 years, but it's going to be another year before we know what the end product is going to be. How do you kind of design flexibly for that type of uncertainty?
It's the root of what we do, and it's really interesting because a lot of developer projects or speculative projects, if you build it, they will come. So we don't even know what the science may be going in the building, and so there's the key words, which it's like trends, right? And if you tell someone a trend is a cellular phone, they'll look at you crazy because that's not a trend, that's a standard. But the trend, which has just been around for 100 years in laboratory design, is flexibility and adaptability. And so the thing we have to look at when we're designing and is creating a modular type of building that can fluctuate between space types, but also have that infrastructure that's available. And it's somewhat of a guessing game. And it's, as we try to design more environmentally sustainable buildings, we still have to say, what, we don't know what's going on in this, equipment area, but let's just say worst case, it's all freezers, right? And we have to upsize the ventilation for that. So in some ways, you have to kind of over-design.
Sorry, Greg. That's my best case if it's all freezers, right? I'm just teasing, but toughest case.
Yeah. No, and I'm sure you have an interesting perspective on that, because when we design, it's 2 to 3 years out, and the equipment that goes in that building might not even exist at that point. And we'll plan around one thing, and it's very often, someone will get a grant or find a new piece of equipment that goes in, and we have to just flex. And there's products out there. There's a flexible electric raceway that you can pop off the outlets and switch it out, and you don't need an electrician to do that. but there's a cost to flexibility, and it's looking at how, for many institutions, it's looking at how often you change a space or a flow, and just figure you're always going to change 25% of your spaces, and build that in as part of it.
Yeah, I mean, I think I've also seen the same trend, which has been that, the new labs that are starting up want that ability to be flexible. In some scenarios, it's easy. It's a matter of putting casters on things and lockable casters and shifting them around. Other times it's not so easy. You have to re-qualify and optimize and certify different products if they move, right? So that's been one thing that I think hasn't, I think that having a tool to help you kind of map that out before you start moving things is an incredible value add, right? Because first of all, it's usually large, bulky items. Second of all, you don't really know how it's going to fit. And I guarantee you, once those labs start filling up, and they do, 2 years after the new lab, it's beautiful and clean and everything has a home, it's full because everybody has needs that happen between that time and 2 years later. And it could be people, it could be equipment. I mean, look at pandemic, we launched a new robotic diagnostic system that takes up a considerable amount of space. So to run 6,000 tests automated a day, you need X amount of space. So the lab design tool helped us a lot, helped our teams and our customers, plan for that before, some of these items actually came into their facilities, right? So there's a lot of things that happen kind of after the planning's done that we have to, that the end users and the labs have to kind of manage and pivot, and these tools are helping us kind of manage through that as well.
And I think I can add, if you add a little bit more as well onto that, I completely agree with Angela, but also the one thing that we're always trying to do is looking to try and future-proof. So, the one great thing about having a tool that allows you to start with a base drawing of this is what you're going to get today, but you can also put some scenario planning in and show what the lab could look like in 3 years, 5 years, 7 years. And it just helps because it shows whether or not there really is space or whether there isn't space. And we do come across places where we know that whatever we're going to put in, that's it. You're going to have to find new space if you want to grow. And it's an important thing to actually be able to discuss with a customer, because there's a cost implication to getting more space, obviously. So I as I say, I completely agree with what Angela's saying, but I also think that being able to future-proof and look forward using the tool really helps the customer move on. I'll just go to mute, I think, at this point.
Alex, I think that there's two kinds of change that we have to be ready for, and this didn't used to be the case. One is sort of this long-term plan change. If you think about the way labs used to be, it would be a 5-year process. You'd be thinking about what the purpose was, you'd lay it out. And some of that obviously still goes on. And think about, for example, let's say hospital diagnostic labs. They used to be designed primarily for stat testing. And a lot of these big hospital systems have now become reference labs as well. So you had to change over to servicing both, a traditional reference lab timeline and a stat timeline. And that had lots of implications with respect to workflows and instruments and those kinds of things. So, but that's sort of a longer term strategic plan. Now, because of the pandemic, we've realized that there's going to be constant, rapid demand for change, and we have to integrate both of those kinds of things. And I think you can't just plan a lab for step function change over a long period of time. You have to plan it for some of this constant change that Rachel was talking about with respect to agility. And I think this is where we have to sort of think about the world being a constantly changing world. It's almost like this lab is going to be like this for a while, but probably a short while. And it used to be a long time, and now it's not really going to be as long a period of stasis as we used to have. So I think planning for change is a big difference, as opposed to planning for the next state, which is what we used to do, right? And this planning for change, I think, requires not only the right tools, and as Alistair said, sort of using them in the right way with respect to scenario planning and road mapping, but also a mindset. And I think that's where the usability and the collaboration and the integration across domains is so important.
Thank you, Gavin. And I also, speaking about collaboration, I would still love to hear your questions, which you can drop in the Q&A or the chat so we can get you guys out there involved in this discussion as well. So an interesting question for you, Angela, we're talking about this need for rapid change, the ability that we can't necessarily plan these things in advance. That has got to place a burden on an equipment provider where you're dealing with, okay, we have to figure out how much of everything do we need on hand, and we have to do that in the middle of talent shortages, supply chain disruptions, things like that. So how are you in your work and with Thermo Fisher kind of being able to meet the demand when the demand is hard to predict?
That's a really good question. So I don't think anybody is outside of the realm of being affected by supply chain issues right now. And so there's a couple of things that I can think of immediately. So during the pandemic, I mean, we basically provide products pretty much at every level of the pandemic response. So from the collection swabs, to the test kits that, the PCR test kits, to the robots that do the testing for you, to the, then to the vaccines. We now have, a giant demand for -80 freezers because, Pfizer Moderna requires this unique storage temperature. So we had some interesting scenarios come up over the last year where, we have clients that come to us saying, hey, we need hundreds of freezers, we have this place where we think they will work. Can you give us an idea of how we could arrange those? Can you give us an idea of the energy output and the HVAC demands that we're going to be looking at? And those kind of scenarios, they need them ASAP. So you're not just looking at, hey, here's the best case scenario, and we're going to give you the product that we, it's sometimes we have to give them the product or recommend the product that we have available to them that we can give to them during that turnaround that they require. And it could be a few months, it could be a few weeks. So we have to look at the type of product based on lead time, as well as the scientific application, a lot more so than we ever did before. But we're also looking at it saying, if we deliver hundreds of a product to a customer, or thousands for that matter, will it actually go through the door? Will it fit in this space? Are the plugs there? And so prepping it, because they can't afford to have any downtime, because that will disrupt the supply chain of maybe the vaccine rollout in that region, for example. So, I mean, there's a lot of different factors at play, but the tools have really helped us in some scenarios work through those questions that our clients are having.
And Regal, similarly, when we're talking about construction, there's obviously, no matter how efficiently you do it, construction takes time. And it's also subject to these same kind of supply chain and talent disruptions. So what lessons have you learned over the last couple of years that you're going to be taking forward in maintaining this, being able to meet the demand for flexible changes?
Yeah, well, it's a really good point, and it has been more volatile, in these past few years than ever. And science, is always evolving, but the disruption to labor and to just simple supplies. There's a company that bought all of the steel for a certain type of warehouse girder, through 2022. And so what we have to do is we have to learn to improvise, and we have to learn to work with the contractor and their subcontractors, and almost, before we would design something and they would figure out where to get it. But now we have to really look at what is available, and it's not just what's available the fastest. dealing with COVID and, trying to find places to store ethanol, and we couldn't even get shipping containers. They were out of shipping container. And so there's just things you don't think suddenly aren't around anymore. And I think in terms of that, for construction, but also for how we think about laboratories, and there was a big shift in design to create just-in-time delivery, and not to have storage in the lab or, on a campus. And that's changed. Places need to be self-sufficient and be able to kind of mitigate any disruptions in supplies. And so that changes how we think about what goes in a building and how much we allocate for storage. And we're seeing it on a global level too, about where we manufacture chips, and that's affecting, the industry here. And so I think, some of the lessons learned are you have to stay nimble. You have to talk to, the equipment suppliers to see what's out there. You have to talk to the building professionals to see what you can actually, make and afford, especially with inflation.
Got it. Thank you, Riggle. Alistair, if you're still with us, I wanted to piggyback on something you said earlier about automating an entire facility, and wanted to get your thoughts on kind of the future of automation in labs and what your thinking is for what that's going to look like the next few years down the road. I think we might have lost Alistair. So let me pivot that question to Gavin, because I know you were talking about lab automation as well, and I think it's a really fascinating topic. When I was a student, I know I longed for robots to do my pipetting for me. So what can you tell us about what kind of automation may look like in labs over the next few years?
Well, I think there's the
Yeah. Okay. So I mean, when you yeah.
Go ahead, Alistair.
Sorry, I think what we're seeing with automation. Hello, can you hear me?
We can hear you now.
Okay, great. Sorry about that. I think we're seeing two types of automation, or two trends of automation at the moment. One is the sort of total lab automation, which everybody's always talked about. And I think what we're seeing on that side is a big change in two things. One is the complete holistics of the total sample journey from collection through to disposition, a kind of vein to brain scenario. And I think we're seeing that happening there, and informatics is playing a much more important role in that. From on the other side of automation, we're starting to see, a whole new world of these smaller, as you say, that you were always looking when you were a student, of these smaller robotic arms being linked up with pipetting stations to actually create an automated solution for sort of the molecular space, for example. So I think we're seeing two different dichotomies going with automation at the moment.
Great, thanks, Alistair. That's informative, and I'm curious, Gavin, since you work on the software side of this, which is obviously a key part of any lab automation. What are some of the challenges in transitioning over to more automation in the labs?
Well, just to, I think, reinforce what Alistair said, because I think the challenges relate to both of those. One is you're automating within a process or a set of instruments. And one of the huge advances that have been made with respect to automation is consolidation of steps into single instruments or single workstations. And that automation has changed a great deal of both the information technology requirements, but also the human workflow that's involved. So part of automation in that regard is to consolidate the steps that are involved and to automate functions that were required in the past, human intervention to transfer samples or to actually, process some of those steps. The second part is to actually automate the entire workflow within a process or a lab. And that's also placing different kinds of information requirements. So the first thing that I think is important is you have to have an enormous amount of information related to that sample that starts out. So there's a huge information chain that follows that sample that has to be both procedural, what are the steps, as well as declarative, what are the results. And each step along the way, if you've got a certain sequence that has to happen, you have to have dynamic databases that can then take the data that comes right out of the instruments, store them in the databases, and very often, based on those results, modify the workflow from that as well. You're seeing, for example, a lot of the new automation systems are actually doing their QA testing themselves. And so when you're getting samples going through the system, they're actually doing their own quality assurance and not releasing until a particular specificity or whatever has been reached. And so what ends up happening is that the workflow becomes designed dynamically by the information technology system. And so there is a huge convergence at the moment of IT systems and data flow, information technology systems, and the physical environment. And so what I think this question relates to is you have to be able to design all of that to take into account this blurring of lines between what's happening in the physical domain and what's happening in the IT domain and the data domain. And in the past, it was mainly recording. Lab information systems would just record what was happening. Now they're actually controlling. And there's a much sort of higher level of fidelity that's required for these information technology systems if they're controlling the process. And so all of this, I think, relates back to this multidimensional requirement that we talked about earlier. When you're designing, it's not just designing for physical layout of where did the fridges go or the freezers, but it's also designing for how are we going to get the information to flow, and what if a sample has to come back and be retested or reanalyzed. So I think the complexity has increased dramatically, even though the results and the goal is to improve operations in a highly dramatic fashion. That does place a complexity burden on all of these design elements. And I think that's a new area of challenge for the instrument companies, for the IT companies, and for the lab design companies who have to really take into account all of these dynamics.
Kind of on that note, I'm sorry, go ahead, Angela.
I was just going to add to that too, because with automation introduces it, well, this idea of capturing data, right, on your whether it's an automated robot or whether it's a freezer, the idea of capturing that data also opens up the opportunity for compliance and audit trails, which is heavily, in a regulated industry. This is really valuable, right? So being able to now take something that used to be maybe a task or an item that was just sitting in a lab, and you record the temperature on a piece of paper, for example, you can now pull the data in and you can actually pull an audit trail. So if somebody says, what was your vaccine stored at? What is the range of that temperature throughout the storage of that vaccine? You can pull it out to the FDA or whoever and say, here you go, this is it. So it's not just at automating a task level, it's like automating things in the lab that we're very much a paper-based system where audit trails exist for sure, but this really adds an efficiency to that that didn't exist before.
I could maybe piggyback on that at the facility level with automating the building. We're designing more and more smart buildings that are integrating with Internet of Things, and facilities wants to track the fans, they want to track the motors that are running and operating the building, and be able to audit and start budgeting when the next replacement might happen, and really looking at the life cycle costs. But with the whole idea of a building automated system and that links into the laboratory information management system, we're going to start, I think, seeing more ways to structure resources like laboratory equipment and know how much storage is available, on one side of the campus versus the other. and start really harnessing the power of our existing resources.
Right. So one thing that I'm kind of curious about, Regal, is, we talked about the tension of we're going to be designing a lab we don't know the end use process for. And I think, automation is easiest when the process is well defined. So how do you, if there's an increased demand for automation, but also increased uncertainty in end use, how do you kind of work to help resolve that tension and still make automation a possibility on the design level?
Yeah, on a design level. So, a lot of the things we always talk about are, creating these kind of, ballrooms, reconfigurable dance floors, and really making sure that we're not building big impediments to rearranging furniture or casework in the lab. And there's few things, a lot of things we can overcome, but a few of them we can't are vibration in a lab building. If the floor of the building isn't built, we can't fix that. But we can add more power, we can add more backup power, or there's solutions to that. There's solutions to increasing the airflow and things like that. So that can happen, but it's really looking at those big things. Can we even get the equipment in a building? And more and more, real estate owners are asking us to look at their existing portfolio to figure out what can we convert to lab and what can we not, to really see how far we can go. And so we can start to get a sense and say, well, this is going to be good for bench work, but this might be a candidate for, some pilot scale stuff. And we can start to look at that as a resource.
I have a question for you, Regal. Is there any trade-off, right, for modularity? And I'm thinking, it's an open question, but I am thinking along the lines of both the scientific process, but also the aesthetic of the facility, right?
Yeah, and that's really good. So it's important, and one of the things that has come up, and lab managers, lab technicians, they are and have been frontline workers through this, and there's a huge burnout happening, just with people that are, and I've seen people struggle with, at the very beginning, hanging shower curtains between workstations, and how do we go to work every day, through this, because we are solving the problems of, and that pressure is real, and so we want to create those environments that people look forward to going into. And we can't, obviously it's one thing to turn to some kind of computational solution and say, we can cram, so many sardines in this can, and maximize. But yeah, there's a real human element to designing these spaces. And so we, we look at access to daylight and how deep the space is, and does it feel like a zone you're going to get lost in? How can we break that up and change it with different elements? And that's an important aspect. I'm glad you brought that up.
For sure. And I mean, I've personally walked into labs that were built in a modular fashion, and all the electrical in this case is hanging from the ceiling, right? There's these giant orange boxes hanging everywhere. And I thought, okay, again, practicality speaking, really awesome, because you can pretty much place anything anywhere. You're ready to go, but is that the lab you want to show the dignitary that's coming in to show them your COVID response? So it's just one of those things. And you mentioned just, the value, where your lab bench scientists or technicians are working, that's there every day, right? So having a shower curtain up may not be, like, maybe there's better solutions, yeah. Right? But we make do with what we have so that we can keep productivity up and keep the labs rolling, right? So yeah. I appreciate that.
And in a big trend, I mean, how important coffee is in the workplace, and everyone on here, is drinking coffee as well. And it used to be you build your, your bench space next to your write-up space right in the lab, and you have that connection. But now, we're separating that with glass. We're still keeping the visual connection. We still want the computational next to the wet bench, visually, but we want that space that you can take a break, you can take off your lab coat, have coffee or a snack, and still feel connected with what's going on at the bench.
That's a really good point. So the human element of all of this, right? How do you, I think that there's an element of change management, that the ability to see a space in 3D or even in augmented reality or virtual reality allows you to kind of be in the space, and as an end user, not the person designing or the person signing the work order or the bill, is having a chance to really have a bit of a say in that, before it's built or before it's designed. I think there's a lot of value in that myself.
We're seeing that a lot too, because the previous process didn't allow for a lot of input, just physically didn't allow for a lot of input from the lab technicians or from the scientists themselves. And part of that is because of the way the process was laid out. And part of it is because, as you said earlier, Angela, the tools were just not there. But we've actually seen a number of instances, and Alex, I think this gets to your point, but it comes to the trade-offs that you make, is when you get input from all of the constituents involved, you learn things you didn't know. It's like sort of the coffee question, right? How important is getting, coffee and all that. And so when you're designing this from let's say an automation optimization perspective or a throughput optimization perspective, you don't always take into account what the implications are for the humans who are involved. And sometimes it's not just to benefit them, but they have sort of this Kaizen opportunity to say, hey, we could do it better because I see it from the ground up, right? As opposed to the design down. So I think one of the areas that has been a big trend is to create a collaborative environment. There are trade-offs, but to get input from a wider variety of sources than we used to in the past. And I think that's leading to better solutions. Sometimes those better solutions mean more flexibility, but it's always better in the sense that there's multiple perspectives that lead to a macro optimization instead of just a micro optimization of a particular workflow. And as you said, getting the users to participate, part of that also is just the emotional buy-in. We have some examples where people would go through and look at their labs in virtual reality before it got built, and it just got them excited, enthusiastic, and so they were willing to accept other trade-offs because they were part of the process, and they felt good about the fact that they had that early view, as you said, Angela.
Absolutely.
One thing that I was curious about, throughout the pandemic, we've seen trends towards remote work. And we also see a lot of big companies looking to be a little bit more decentralized, where maybe they would have a big company headquarters in a big city somewhere. Okay, now we're going to have an office here in Texas, and we're going to have it here where real estate's cheaper, where maybe the housing costs are lower, so we can people with talent might want to do that. Do you think we might see this in lab spaces as well, where rather than have a giant facility in Boston where it's expensive, maybe we have a lab over here in New Hampshire, we have a lab over here in Vermont, we have a lab, in Ohio. Do you think that's something that we might see in labs, the way we're kind of starting to maybe see the beginning of in offices and other commercial spaces? Regal, you'd probably be the one who'd hear about this the most, so I'll ask you.
Yeah, I mean, I would say, Alex, it's already here. Like, it's been here for a while. I mean, I think before we had automation, we had a price comparison, and can we put a lab in India or a lab in somewhere where we can follow that kind of automated but on a different scale kind of path. And yeah, I think what we're seeing though is it's possible, but researchers want to be around other researchers, and there are real hubs, and Boston is always going to be Boston, and those orbits are going to attract people, and they're just getting bigger. And so I think you may have an area where you can outsource processes or repetitive kind of a task, but when you're looking at the real experimental bench, that's always going to be in a central area.
And just to jump in on that too, like I think from our experience in working with our clients, we've seen the pandemic shift and kind of make that question to our lab scientists, saying, how many of us really need to be here today at the lab? You know, how many people are doing bench work that really needs to be done today? You know, am I growing cells? Yes, I need to be here every day to make sure my cells are growing and happy. But if I'm running an experiment that's a week long on an automated instrument, I can probably check in because I have sensors everywhere on that instrument. I can check in remotely, you know, and work a different way. So I think from an academic standpoint, academics don't work on a 9 to 5 anyway. So that doesn't really, nothing's changed, I don't think, for them, except they're not in the lab maybe as much collaborating and going to the conferences. And I think the more we can utilize digital tools to enable those conversations is what, so the program I work on is really around enabling people to connect in a virtual scenario in a meaningful way that is helpful and helps them move forward with their science, right? So I think the value of being together physically, we're starting to think about how are we doing that? What is that? What are we pulling from that? Because scientists are heavily collaborative in how they do their work, but how do we do it a little differently? And I think they're starting to, I think we as a society are starting to even in general look at that in general as a way of, can I do what I need to do? Instead of sitting in 4 chairs on a stage, can we do what we need to do on a Zoom panel instead, right?
I think the software technologies enable that when it's appropriate, and then they facilitate collaboration even when you're live in person when that's appropriate as well. So if you're, as Rachel said, you know, you pull out the iPad, 3 or 4 people are looking at it, maybe there's a VR experience, or maybe you're connecting to real-time data about the lab. So the digital technologies, I think, have actually facilitated, Alex, this vision that you have of sort of maybe satellite labs or remote labs, where they don't always have to be in exactly the same place that they have been, because we have the ability to do the things we need to do remotely. And I think quality of life and access to talent is really important, because we're looking at a huge labor shift in the way that lab markets are actually being affected by what's been going on, and people are making lifestyle choices first as opposed to career choices. So it's almost, in my mind, the answer to your question is, I don't think we have a choice. We have to do these things. And now the question is, how do we optimize the operation, design, adaptability of these labs using these digital tools in a way that makes everybody feel connected? And, you know, these capabilities now make it so that you don't have to be in the same place to have a meaningful conversation about certain things. And 90% of, I think, operating and designing and optimizing these labs can be done in very quick conversations that can be virtual, and they can be collaborative. There's no reason why we couldn't put up a shared screen of our digital twin of the lab, have a conversation about that, talk about where things are going to go, talk about what the science needs to be, and then finish that meeting and not have to have people get on planes. And I think that's another huge advantage of this digital infrastructure.
Yeah, I think there's. I just put one sort of word of caution into that. I think, you know, one of the worrying things about Zoom meetings or WebEx or whatever digital meeting type we use, that lack of face-to-face sometimes loses those people who have probably got something to say but don't know when to say it. And that's really an important point, and I think it's something that we need to bear in mind. And I don't know if this is something that, as we build digital platforms, that we can actually look. And I know we have the chat functionality, but not everybody, you know, feels comfortable putting in their questions or feels totally comfortable actually being part of a virtual meeting. And I think, you know, the pandemic forced it on us. I think some of us got very deep down with it, no problems, but other people are still struggling, I think, you know, with that whole Zoom piece. So I think there is a person piece behind this, and I think we probably need to figure out how we make the virtual totally inclusive, not semi-inclusive.
Yeah, I think that's a really interesting concept, because the two things in the industry when we're designing a building we look at are efficiency, but then it's also been this je ne sais quoi of collaboration, and how do you get historically extremely bright introverts together talking. And there's a lot of documentation about laboratory life is a book by an anthropologist in a lab talking about we need narrow doorways so people bump into each other, or not enough toilets so people line up outside and start talking. And we know, historically the anecdotes about how people collaborate, it's because there's only one Xerox machine, and people wait, or, and so I think it's a fuzzy thing that we don't have any real way to measure, other than kind of anecdotes. And I know there are companies out there that have been trying to put together, lighting systems that run through Ethernet where people are in buildings. Until we have that kind of information,
I think Regal's breaking up a little bit, but curious to know, Angela, from your perspective, looking at some of these issues of remote work and collaboration, are you seeing orders of different kinds of equipment, or are people building satellite labs, or are you seeing any of this on the ground right now?
So I don't know that I can speak to that fully. I haven't been on the ground in the field for a couple of years, but I will say that I've seen a giant demand. So science is kind of in the limelight right now, right? Like this is our time to shine. And there's a lot of focus and energy on both the pandemic response and treatments, but also like cell therapy and gene therapy. And, there's just, I feel like wherever people can find a space that makes logical sense to put a lab, to set up their operations, that has the requirements, the building requirements, I feel like this is kind of where we're at right now. They're finding those spaces, or making them where they have the real estate, as Regal said. So I don't know that it's really a satellite situation as much as there's a supply and demand issue for space in labs, which I think another piece of the tool, which we haven't really covered, is the ability to really maximize the space. So how do I utilize every square inch or every square meter of the space that I have? And whether it's storing products, whether it's operating equipment, having personal workspace for the employees. I mean, this is a big deal for our clients. And there's never an abundance of space, I would say, in general, in the lab environment. So this is really something where we can, wherever it happens to be, really utilize the tools to help that in general. And as far as the, what we're seeing in the field, I think from a collaboration standpoint, I always look at our sales team as kind of the hubs and nodes. So we kind of have an idea of what's happening at all the major accounts, from academic to pharma to government. We're here to help them in so many different ways. And not being physically there has been a real challenge for a lot of our team members that have been with us. We have a lot of tenure, right? And so there's a lot of people that have had a really hard time staying connected with what I call the beat of the lab. Because what we're talking about here, as we go through this example, is really an ecosystem. We're talking about the lab ecosystem, from how you set it up to how it functions, who's in it, and who's coming and going from it. And we're the coming and going, right? Like our team comes and goes all the time. And that's how we understand what's happening, and we can connect people. We do kind of act as connectors in a lot of cases. So I think from our perspective, it's been really challenging getting people to accept Zoom meetings or Teams meetings. It's a behavior shift for everybody, including our clients. So there's been a lot of challenges, but I think there's a lot of good that's coming out of it as well. So we're able to pull together decision makers and stakeholders quickly across the globe into the same meetings. We're able to build consensus faster in these meetings. So I think a lot of times where we're pushing the envelope and trying to get the change in behavior, we're also seeing that that change may stick because there's a lot of benefits from that as well.
I think I have 2 points to add to Angela's profound comments. I think one of them is that just because we're remote doesn't mean we have to be in a virtual Zoom team meeting to use digital tools to collaborate. There's asynchronous collaboration as well. Angela goes off and she creates a lab. Regal looks at it and in his time zone or whatever, he modifies things. So we're actually using digital tools to collaborate, but we're not necessarily in a Zoom meeting with the Zoom fatigue or the Teams fatigue and all that. So there are ways of using digital infrastructures across time zones and across asynchronous communications that facilitate the use and deployment of these labs in different locations. And the other point I want to make about this, and Angela knows this extremely well, is the pandemic particularly has created a knowledge and a recognition, not just that science is critical and important to us, but that the pandemic, for example, in this particular case, is turning into an endemic. It's going to be here. It's just like the flu. And the consequence of this is in part related to where these labs are, because a lot of big companies are putting testing labs in their own facilities. They didn't used to be in the lab business before. They were in the package shipping business, and now they're in the lab business. So part of it is building labs in places that there never used to be labs before for purposes that we're not used to as well. And one of the huge opportunities is to distribute out in these highly automated facilities and highly distributed facilities tasks that would normally have required shipping samples to a lab. And because of the endemic nature of the COVID situation, I think that's also a trend that we're going to see going forward. So the ability to design labs in the basement of a warehouse or an office building or something like that for the purposes of whether it's rapid testing or whatever the other situations might be, that's a new situation for us, but I don't think it's temporary. I think this is something that's going to be part of our ecosystem, as Angela put it.
All right, Gavin, thank you so much for those comments. And I think that's really a perfect note to capstone this conversation on. I want to thank all of the panelists for really a thought-provoking discussion. And I want to thank all of you who are participating and watching this webinar. Thank you so much. We do appreciate that. And I'm going to kick this back to Dana to close us out.
Thank you so much, Alex, and thank you for moderating today's event. I really appreciate it. I think we had a fantastic discussion, lots of thought leadership. We did get a couple Q&A questions that we haven't been able to go throughout the panel discussion, but we will follow up with those people individually. We've also recorded this panel discussion, so we'll share that with anybody who's in attendance. If you want to share that around your teams or departments, we're happy to do that. And if you think of any questions you have for our panelists, feel free to follow up with me directly. I can email them on and we can get answers or get you connected to have conversations with them as well. So thank you so much for everyone attending today, and thank you everyone for being on the panel. I really appreciate it. Thank you for your time, and everyone have a good remainder of their day. Thank you, everyone.
Thank you.
Thank you. Bye-bye.
Bye.
Bye-bye, Alan.